Hello, everyone, and welcome back to another Menlo Community Call. I'm Mimi, and I'll be your host today. Thanks so much for joining us. It's really fun seeing people join from all over the world. So wherever you're tuning in from, we're really happy that you're here. And if you can't stick around for the whole stream, don't worry. We'll upload the replay to YouTube afterwards, so you can always catch up wherever you've got the time. And if you're here live, we would love to say hi to you. Drop a hello in the chat. Let us know where you're watching from, or just tell us what you're excited to hear about today. And we'll be checking our chat throughout the stream. So if you've got any questions, we'll do our best to answer all of them. And if this is your first community call, here's a quick overview. Every week, we bring everyone together to share what we've been working on across Menlo. And sometimes that means showing off our new features. Sometimes it's talking through some technical challenges that our team has been facing. And sometimes it's just sharing the little wins that don't always make it into our social posts. So the goal is pretty simple. We're really trying to build in public with our community and bring all of you along for the journey. And this is what we have for today. We'll start with software updates, then a few updates on our ongoing work with the manual, then what's been happening on the manufacturing side, then we'll move on to our brain team, which is a particularly exciting segment for us, and we'll be sharing something very new we've been working on. And towards the end, we'll also give a few housekeeping updates, including the new website and our careers. So there's a lot to cover, and let's get straight into it. I'll pass the mic over to Ashley.
Yep. Thanks, Mimi. So hello everybody. My name is Ashley. I'm the product designer of Menlo. So for today, so there's a lot of exciting things going on with the platform team, and um, so what I wanted to share a part of it. But first, I want to quickly go through like what we mean when we say we're building the platform for robotics. So you can think of it like an ecosystem for robotics where user can like register and then connect their robot to the platform, whether it's like a desktop app, mobile app, or web app. And then ideally they can control and manage and monitor the robot from there. But it doesn't just stop at there. Ideally, you should be able to train and then share the policy, like the training policy, and publish to the hub. And then they can get like the and then they can get like they can get and download the policies from others people and then deploy it back to the robots using the platform. So that's the foundations we're heading towards for the platform team. Currently we're working one of the main piece, which is the mobile app. So for the MVP versions, we wanted the user to be able to connect the robot to the platform, and then they should be able to control the robot offline. So that's the MVP versions we aiming for. So I've been working on the wireframes for it, but one thing to set expectation though is that the Wi-Fi is not finalized yet. So for today, I will be sharing the visual directions for the mobile app. So here are some UI components and then some of the main screen. Hopefully it will get you understand like the visual directions we're heading towards. So for we still like strictly stick with the brand guideline of Menlo, like the colors and then the fonts, etc. But for the mobile app side, I wanted to do a little bit different from other apps. So what I'm trying to achieve here is like the 3D hardware visuals aesthetics. So when user like control the robot, it will feels like they actually like holding a piece of the hardware of the robot itself. Yeah, so what I'm trying to achieve here is that when they tap on the buttons, it feels like they actually like tap on the hardware, not just like a flat elements on the screen. So for the cockpit design, which is where user control the robot, I wanted to mimic the UX of a joystick. So user can like move the robot in four directions with the left joystick buttons, and then at the same time they can rotate the robot with the right joystick buttons. And of course, there's gonna be like emergency stop buttons. And some other elements like they can see like the battery, and then they can change the mode of the robot, like balance, then or dim. Um, so yeah, so this is the visuals. I've been working on. So some other elements that I also worked on is like the motions for the which I will be using for across the onboarding screens. So the idea here is that the robot, like I'm using like the figure of the Asimov one, but ideally what I want to refine further is that the robot will like fold and then fold into like multiple form factors, because what I wanted to express is that with one foundations we can have like multiple form factors for like different cases. Yep. So I think that's all from me for the latest update for the mobile app. So if you have any like feedbacks or some creative ideas, leave comment. Thank you.
I think it looks really cool, actually.
Thanks, Mimi.
If you guys have any questions or comments for Ashley, leave them in the chat. Otherwise, I think we can move on to Yuki.
Okay. Hi, good morning, everyone, or afternoon, evening, wherever you are. My name is Yuki. Currently I'm working on the manuals for the Asimov one. So if you guys have seen the last update, we have kind of show you guys what we kind of strive for in the manuals, right? So we're trying to make sure that when you receive an Asimov one at your doorstep, you open up the box, you have all of the manuals, all of the instruction, as easy as possible for you to assemble an Asimov one yourself. So we kind of take a lot of inspiration from how we do like a Lego manuals and how you do IKEA designs. So throughout the last week or so, we've been working really hard, assembling, disassembling many times to make sure that like we really got the process of like assembling a Asimov one really nailed down, right? So this kind of like all of the works that we have done. I want to show you guys what. So we have also migrated this over to the new to the our official doc also, which is gonna pending update soon. Right now, just gonna give you guys a preview of what that will look like. So you guys probably have seen all of the previous version already with the assembly step. But now, if you go into, let's say the let's pick one, which is like the ARM modules, right? You go to preparation, you'll see all the parts that you will need, right? And then you'll see all the mechanical part list. And what we kind of upgraded this time around, and make sure that if you hover on one of them, you know exactly what part it is in all of its shiny glories. All right. So yeah. So it's like, 302B is not very good, easy to visualize. So yeah, we make sure that we have all the visualization done there for you, so you know like which part we are referring to. So we go into, let's say, a sub-assembly A. Yeah, so you can go down and see we have all the pictures of like what the motors look like, how it should be facing upward, downward, like what is the portion, right? You can see like the next step down here, you can see like the port below. So like all this is making sure that like when you stop at the step, you have all the information that you needed to assemble that particular step. So no need to like keep clicking like back and forth between the tab or scrolling up and down. That's not what we want. So if you're on a step 2, you know that, okay, you need to take part 304B. This is a part 304B, right? And then slot into the motors. Yeah. So this is a kind of like, user experience that we want to deliver to all of our Asimov 1 customers, right? We're gonna make it as easy as possible to assemble Asimov 1, as we already know that like this is gonna be a hard endeavor. So we're not gonna make it harder than it need to be. Yeah. So that's one thing. I really love to get you guys feedback on this when we release it, maybe on forums or on Discord. Yeah. So yeah, it took quite a bit of effort, but we really like how it's come out. So the other things I want to share with you guys is that beyond just having the visualization and then all the picture and parts, we will also like to have 3D visualization of how we're going to do assembly of Asimov 1. So right now we are creating a new tools internally to help us do just that. So this is origami, something that we might consider open source later, so everyone can help. Like, if we create a custom part for Asimov 1, we would love to see how to assemble that into Asimov 1 also. So you can actually select the part, you can move it up and down, you can create like nice visualization on how each bolt should go into what holes, and kind of like, yeah, just get a nice view of like your assembling of the parts. And this will also go into the manual to make sure you can go around, pan it, and get a 3D visualization of how you assemble an Asimov one yourself. Because we know that it's kind of hard to just like, get it from just a 3D visualization or so. So yeah, you can actually add more parts into it like that. Yeah, you can move up and down. Yeah, so this is what we have been working on. Quite excited to release this to community soon. There's still like things that we need to work on, but yeah, pretty exciting time ahead for us. Yeah, I hope all the Asimov one pre-order and customer and even communities, right, will find this process much easier, and maybe you can even assemble a virtual Asimov yourself, right? Could be a fun exercise also.
Thanks, Yuki. There's a lot of positive comments for you in the chat.
Yeah, we are so yeah, we also working like the fusion exploded like view, right? That's what we have previously on the manual we currently have right now. But in the problem with that is like it's just a diagram. It's still 2D visualization. It's kind of hard if you like it's kind of hard to describe how you have to rotate a certain part so that you can like slot in a bolt here, slot in a bolt there. So that's why we kind of have to like couple up a bit more of a custom solution so that like you can rotate it within the manual itself, right? Which hopefully will be much easier to visualize the part. Yeah.
Okay, shall we move on to Frank? Thanks, Yuki.
Thank you, Mimi. And I'm Frank, managing the supply chain and the manufacturing in Menlo. And I will give update about SMO1 the fulfillment status. And first update is about our application unit building. And now we almost get most of the material ready at the CM site. And we also finished the fitting check as planned. And I will share the picture and the videos about the examples later. So next step, and we start the assembly and the test at our CM site, and our PTT will fly to China with CM to finish this. About our first batch building, and it's also on the track, and the just change is we might postpone the start of manufacturing of the first batch of mechanical parts by a few days. But overall, there's no impact for our delivery schedule. We're still targeting to ship out the first batch of unit within the August.
I think, Frank, you're muted.
Oh, sorry. Okay. Yeah, I think so. That's the picture of our mechanic parts for the first verification unit. And also it's the video about this mechanic parts. Yeah, and also share the video about when we are doing the fitting check. Yeah, I think let's all update from my side for the moment. I think as said, and our PD team will be in the CM site next week and to do the assembly test for our first verification unit, and we'll share more progress later. Thank you.
Thanks, Frank. Should we move on to our brain team? Joe, are you ready?
Yeah. Hello, everyone. How are you today? Okay, I'm sharing my camera. Yeah, this is we call it a micro factory. It is a version from Asimov design. As you can see that we have 2 arms, and each arm 6 degrees of freedom. Also, we have a gripper. This is a gripper at the end effector. We also have 2 wrist cameras, and we also have one or multiple scene camera, maybe at the top or left side, right side. I'm not sure that you can see my camera. Can you see my hand moving?
Yep, we can
in
see
the camera. Yeah. Okay.
Yep.
So this is micro factory, and we can control the arm right now. We can control the left arm using the space mouse. This is with this device you can control 6D, 6-dimension movement. It is translation X, translation Y, and Z. Also, you can control the orientation, roll, pitch, yaw. We can use multiple devices for control the arm, but it is for later. Right now, I will show you the demo using the space mouse to control the left arm. Okay, we can control it up, down, moving up and moving down. See, and left and right, up, down, left, right, and forward. Yeah, and moving forward and moving backwards. We can also control the orientation of the gripper of the end effector. Okay, this is row. This is row movement orientation of the gripper, and we can also control pitch movement. Okay. And yaw movement. Closing gripper, opening gripper. Okay, move back to the readables. So I think we can actually use it for controlling for teleoperation later, and that's our current status right now. Yeah, that's all from my side.
Thank you, Dawn. That looks very cool. Alex, do you want to follow up?
Yeah, okay. I was share my screen. Okay. Hello everyone. I'm Alex. I'm a machining engineer of Menlo team, and today I'm very happy to sharing about what we have been working on in the last few weeks, which is we are teaching a whole new robot to series in X But to be in short, we're gonna change VOA model to teaching the microfactory form factor, our new form factor to really do the task. So what it is? So here's a challenge we're making. We have a whole new bimanual torso and two 6-top arms, and also the gripper. There's no model or public data has ever seen it. So which is we don't have any public data for this form factor. Yeah. And the second problem is we don't have 10,000 of collected data operation data for it to change. And the last one, we need to deliver one policy that can really see the whole picture, see the whole, and output the policy to really uh, do the task like pick the cube out of the box, like you can see in here. And yeah, it must be closed loop. And yeah. So how we approach this problem, we decide to simulate the whole data in the simulation, and we change the model called Momo to resolve this problem. It takes 4 camera views. It is RGB camera views, and also read the plain language instruction, like put the red cube in the green box, as you see in this. And also it's no need to read the real-time robot state in order to output the continuous joint targets for the both arm and gripper to redo the task, like you can see in this. Yeah. So what I actually do is we need to rebuild the whole road in simulation. We take the URDF from our mechanical team, and then build the microfactory in simulation, and also put all the object in that. Next, we need to generate all the trajectory script that the IK algorithm to really pick and place the cube. Yeah, basically we need to using some algorithm to really solve tasks, and we record all the trajectory of the arm and simulate all the data in simulation, and then we use that data to find through the MomoBot MomoBot model. The action expert is changed from Strat, and the language model of MomoBot is essentially adapt because it's trained with a very small learning rate. We train this with 100% of synthetic data on our RX 6000 Pro. So how's it went so far? We see it's working on the validation test. We seeing the loss still improving, and also the accuracy of solving tasks is improving as well over time. As you can see, it's improving from 31% to 80% right now. And to be honest, it is still training right now. It's even haven't seen the whole data yet. It's not an end of epoch, so yeah, we are still looking at it. But yeah, this is some demo on validation sets. You can see after it can really pick and place the cubes. There's some kind of task we are checking on, like move the cube out of the box, or pick moving from into the box, or dual arm doing the same thing in parallel, and moving the box between the boxes. This the thing is this is still in simulation, and the validation data is still the same with the training data. We want to validate the model more, so we decide to test the robustness of the model. Like we changing everything. As you can see, this is very like in the training data. In training data, we left the background is all white, right? And also the color of the arm is fixed, and we only random the camera views and lights and other. So what we do when we want to test a robustness, like we changing the whole environment. As you can see, we're changing the floor. It's very like complicated background. Also, we changing the world outside. So basically, this is totally different environments. And we also run the same test on the same on the same validation test, and we can see is the model still can hold the accuracy very decent. If we change to the room scene, and also change the camera views. The accuracy is just a lot, a little bit. And if we like doing like much more challenge, like just like changing the color of the arms, and also change the model, and also zoom in a lot to each cam. So basically, it's totally different view, but the model is still performing well. And here's some demo of yeah, you can see after changing to the new scene, it can still like performing tasks. It can, yeah. This is the task, and this is how it's doing. Yeah. Yeah, and this is end-to-end closed loop. Only just no in the middle. Like we need to, yeah. And this is a special case that it's missed a queue, right? On several time, and it can like really retry to finish the task. You can see. Yeah. So it can retry if it is fail. Like this. Okay, so that is our work in simulations. The next is much more challenging. We are gonna deploy this on real microfactories that we have in the Simulink Square office right now, and try to resolve the sim2 real problem for for this model. Yeah, that's our next challenge. That's it. Thanks you guys for listening. You guys have any question? I'm very open to to explain more about the VOA of microfactory. Or
Oh,
we
and
can go.
Alex, I think we have actually a lot of comments, so I'll just flash them on the screen, and we can answer them maybe. So there's a question from Doug Ironside. Does the microfactory have stereo vision for depth perception? So maybe Do can answer as well.
Yeah, I think Do can
Hi,
handle
hi.
this question.
Actually, we can support multiple camera. We have in microfactory we have right now we have 2 real sense cameras, and we can support it. But I understand that still need we need to solve a lot of technical problem, like if we want to store the depth frame, the depth sensor data, or we need to streaming. We need streaming for depth data, but that's for later. But in the robot and microfactory, we can support. But also it depends on the brain team. It depends on the VOA, depend on the AI that you're using.
I think we have Tati in the comments answering questions for us as well. Thank you, Tati. We're still experimenting with the most optimal combination, but in this form factor, we can mount lots of cameras of all kinds. So hopefully this answers your question, Dark Insight. We have another question. I think this one is for Alex.
For now, we are doing pure in musical. We are using pure musical to simulate everything to do static data. Yeah. We and use Momo board to change this model. We haven't adopted the MJLab yet, but yeah, in the future we might be like integrate our own in MJLab, so everyone can use it to change their own policy. Yeah.
Another question. What happens if the robot has to crisscross its arms? And does it delegate the workspace in clean house?
Hi. For the bimanual robot, of course, we have the workspace interfere with each other. So it based on the manipulation policy that we deploy should solve it. But in the robot, in the hardware and firmware side, we also have protection for it.
We also have Ishnit in the comments answering our questions. Our brain team is really active in the comments. Shout out to our brain team. Ishnit said it can technically crisscross its arms as well, since we use IK to generate training data. So if we use more complex IK path avoidance, it's possible. Okay, I think that's all the questions for now. If you guys have any more comments, feedback, all of that, may I redirect you to our Discord, where our team can answer more in depth if you guys would like to discuss this in a bit more depth. I think next up we can move on to our housekeeping. So namely, we have exciting updates on our new website. So our new website has a brand new look. So we've been working really hard on, polishing up how we're presenting ourselves to you and to our community. So whenever you have the time, you can scroll through our new website. We're still working on it, so there's still going to be some issues to be resolved. But for the purposes of this call, I think, namely, I will highlight a few things. So a lot of the Asimov-related content, we try to flesh it out a bit more on how we think about open hardware and what Asimov actually means to us and our plans for Asimov. So we try to consolidate it all into one sort of coherent package. You will see a lot of Asimov 1 related information and links on the product page and some of the coming soon teasers that you may be interested in. And secondly, I wanted to highlight our partners page. So as you know, we are working really hard on opening up Asimov and how we're coordinating with our partners, and we really believe in distributed manufacturing. So if you're interested in working with us, partnering with us on any of these matters, just know that it's an available option for you to get involved with us. And otherwise, I think you'll just scroll through all of our new updates on the website. And I think the next update is from Herman, which will also be related to our new careers page. I cannot see Herman. I can see Herman now.
Hi everyone, it's really great to meet you all today. Let me share my screen. Give me a second real quick. Yeah, so this is our new careers page. Thanks so much for the team for getting it done. It looks really amazing. I think we have lots of different roles that we're hiring for. We're hiring under the administration, software, hardware, field engineering, go-to-market. We also have our internship program, our brain team. So yeah, I look forward to seeing each and every one of your applications. I guess I'm also on the lookout for any recruiting partners who are based in the US. So this is a shout out if any of you are interested to be a recruiting partner for Menlo. Do drop me a DM on LinkedIn, or you can just email us and then we can take it from there. Yeah, I look forward to talking to each and every one of you soon. See ya.
Okay, do we have any more last minute Q&A from the community for our team? If not, maybe I can just do our usual spiel, closing spiel. Please feel free to reach out to us over our Discord, socials. I'm dropping the links in the chat. You know where to find us. But I think for now, that's a wrap for this week's community call. Thanks again for joining us. We always appreciate you taking the time to spend part of your day with us. If you enjoyed today's stream, make sure to like, subscribe, and follow us through all the links that I've just dropped. And if you'd like to, even more behind the scenes updates, come join us on Discord. That's where a lot of the conversations actually happen between these weekly calls. We'll be back again next week with another round of updates. And until then, thanks everyone, and we'll see you soon. Bye everyone.